Hello, math buddies! Today we're going to solve problems involving permutations. I am Cherdons and welcome to Math TV. Let us begin by having a quick recap. We have linear permutation, refers to the number of ordered arrangement of objects in a line. Next, we have distinguishable permutation, different permutations of n objects where some of them are alike or the same. Number 3, it is the circular permutation, the circular permutation of n objects arranged in a circular manner. Let's have question number 1. 7 construction companies are looking for engineers. If there are 4 qualified applicants as cadet engineers, how many ways they can be assigned? The value of n is 7 and the value of r is 4. Our formula, permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. Substituting the value, permutation of 7 objects taken 4 at a time is equal to 7 factorial divided by quantity 7 minus 4 factorial. Simplifying it, we have 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. Cancel out 3 factorial. We left with 7 times 6 times 5 times 4, which will give us 840. Therefore, there are 840 ways. Next problem. If a committee has 10 members, how many ways can the committee select a president, vice president, and a secretary? The value of n is 10. R is 3 because we're dealing with president, vice president, and secretary. Our formula, permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. Plug in the value, permutation of 10 objects taken 3 at a time is equal to 10 factorial divided by quantity 10 minus 3 factorial. Simplifying it, we have 10 times 9 times 8 times 7 factorial over 7 factorial. Cancel out 7 factorial. We have 10 times 9 times 8. It is equal to 720. Therefore, there are 720 ways. Problem number 3. How many ways can the letters in the word mathematics be arranged if letter A, there are no restrictions? Let us count the letters in the word mathematics. Very good, we have 11. So the value of n is 11. Let us now count how many alike letters we have. 2M, 2A, 2T, 1H, 1E, 1I, 1C, 1S. 2M is your P, 2A is your Q, and 2T is your R. Our formula is equal to n factorial divided by p factorial times q factorial times r factorial. Plug in the value, we have 11 factorial divided by 2 factorial times 2 factorial times 2 factorial. Simplifying it, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 times 2 times 1. Cancel out 2 and 1. 4 and 2 share a common factor of 2. 4 divided by 2 is 2. 2 divided by 2 is 1. We can cancel 2. We left with 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3 over 1. It is equal to 4,989,600. Therefore, there are 4,989,600 ways you can arrange the letters without restrictions. For letter B, the vowels are always together. We have A, E, I, M, M, T, T, H, C, S. We will group the vowels and count it as 1. Then 2, 3, 4, 5, 6, 7, 8. The value of n is 8. We have 2m, that's your p. 2t, that's your q. Our formula is equal to n factorial divided by p factorial times q factorial times r factorial. Substituting the value, 8 factorial divided by 2 factorial times 2 factorial. Remember that we have 4 letters in the vowel group and we can arrange them in 4 factorial way. So we will multiply it to 4 factorial divided by 2 factorial. Why? Because we have 2A here. This is your vowel group. Simplifying it, A times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial times 2 times 1 times 4 times 3 times 2 factorial over 2 factorial. Cancel out 2 factorial. Then, cancel another 2 factorial. 4 and 2 share a common factor of 2. 4 divided by 2 is 2 and 2 divided by 2 is 1. Calculating it, 8 times 7 times 6 times 5 times 2 times 3 divided by 1 is equal to 10,080 times 4 times 3 is 12. So we have 10,080 times 12, that is equal to 120,960. Therefore, there are 120,960 ways we can arrange the letters if the vowels are always together. What if the vowels are never together? That's letter C. Vowels are never together equals the total number of ways we can arrange the letters without restrictions. We already solved it. That's the question in letter A. Minus the vowels are always together. We already solved that too. That's the question in letter B. Plug in the value we have 4,989,600 minus 120,960. That is equal to 4,868,640. Therefore, there are 4,868,640 ways we can arrange the letters if the vowels are never together. Again, the question is, how many ways can the letters in the word mathematics be arranged if letter D, the vowels and consonants are always together? We have A, E, I, M, M, T, T, H, C, S. Vowel group, then the consonant group. 1, 2. So we have 2 factorial. Times, we have 4 vowels. So we have 4 factorial. Over 2 factorial. Because there are 2 A's in the vowel group times 7 factorial. Why? Because we have 7 consonant letters. Divided by 2 factorial times 2 factorial. That's for 2 letter M's and 2 letter T's. Simplifying it, 2 times 1 times 4 times 3 times 2 factorial over 2 factorial times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial times 2 times 1. Cancel out 2 factorial, then cancel another 2 factorial. 4 and 2 share a common factor of 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Now, 2 times 1 is 2 times 4 times 3 is 12 times 7 times 6 times 5 times 2 times 3 divided by 1 is 1,260. So, 2 times 12 times 1,260, it is equal to 30,240. Therefore, there are 30,240 ways the letters can be arranged if the vowels and consonants are always together. Problem number 4. Find the number of ways in which Anna, Beth, Che, Dina, and Edna can be seated at round table, such that letter A, no restrictions are imposed, and B, Anna and Beth always sit together. Let us solve letter A. No restrictions are imposed. The value of n is 5. Our formula is equal to quantity n minus 1 factorial. Plug in the value. 5 minus 1 factorial is equal to 4 factorial. Simplifying it, 4 times 3 times 2 times 1, it is equal to 24. Therefore, there are 24 ways the girls can be seated at round table without restrictions. Next, letter B. Anna and Beth always sit together. So Anna and Beth must sit together. Then we have Che, Dina, and Edna. Anna and Beth count as 1, 2, 3, 4. The value of n is 4. Our formula, quantity n minus 1 factorial. Plug in the value, quantity 4 minus 1 factorial equals 3 factorial times 2 factorial. Why? We need to multiply it to 2 factorial because Anna and Beth can change their seats. Simplifying it, 3 times 2 times 1 times 2 times 1. It is equal to 12. Therefore, there are 12 ways these 5 girls can be seated at round table if Anna and Beth always sit together. I hope you enjoy our discussion for today. See you again for our next lesson. Thank you. Have a nice day and God bless everyone.